So my name is Jasmine Eggleton and I'm the Commercial Account Executive here at Sofar. And I'm joined today with Antti Lindfors from Luode, who is the director. And he'll be sharing his experiences that he's had with the spotter, and obviously very hands-on experience as well. So can talk from very much experience. So just a quick background on Sofar. So Sofar are an ocean intelligence company based over in San Francisco. But as you can tell, maybe from my accent, I'm actually based in the UK. So we're quite global. We work all over the world, but all our engineers, all our oceanographers and everyone, production's all based over in San Francisco. So when I discuss that I sell wave buoys for a living, everyone automatically thinks this big massive wave buoy on the left here, but actually we're talking about the one right on the right, the really tiny small one, the Sofar Spotter buoy. So the Sofar Spotter buoy, as you can see here, is a really small low-cost solution. It is completely solar powered, so there's no need to change any batteries. We have over 10 million ocean hours. We've thrown them out of aircraft. We have them moored. We have them as free floating drifters in the global oceans as well. So they can withstand very harsh environments. So they're really easy to use. You can literally, you don't need a degree to use one. You can take the lid off, you can flick a switch, turn it on, throw it into the ocean and start collecting data. It's that easy. And you can do everything remote with the spotter as well. So we can communicate to and from the spotter with either cellular or iridium. So obviously it's dependent obviously on what location that you're in. And we can send that data either through an API or our online dashboard, which I'll talk a bit more in a minute. So the spotter itself collects wind, wave, sea surface temperature, and barometric pressure at the surface. So that's all contained within the buoy itself, and that's all as standard as well. So this is just a quick snapshot from our dashboard. So it just gives you a quick snapshot of the most recent data update. So you can see all that data here. It also comes with a GPS location and a timestamp as well. So this is what our dashboard looks like online. So you can see all your spotters all in one place, because obviously Luode are working with not just one, but multiple. So you can see them all in one space, really quickly and really easy to use. So you can also connect to and from the spotter, as I mentioned previously. So if you go into the settings, you can also change what mode you put the spotter in. You can change the update rate if you wanted to. For example, sometimes people like to increase the frequency when there's a storm coming, just as a quick example. And so you can do it all through there. If you have cellular, you can do firmware updates, for example. And then we can also set up custom alerts. So when we're talking about operations, if you're, and most of the time people need to use wave height for operational purposes, we can also set up alerts. So if it goes over a certain threshold, which means that it's not suitable for operational purposes, then it can send an alert to you, and then you can help reduce and stop operations if it goes over a dangerous threshold. We can also set up like GPS fences for the buoys as well if they're moored. So then you can get all these different features available. And also a nice feature that we've enabled, especially as Antti is working up in Finland. So in the more Nordic countries that don't get as much sunlight, I know that we mentioned that it is solar powered. We have a nice feature called GPS sleep. So it helps like reduce the power intake of the actual buoy itself, so we can increase the efficiency of the actual buoy and to make it stand within these conditions as well. So the spotter wave buoy can be used as a standalone, or we have the option of a smart mooring. So the smart mooring is a load-bearing power and communications cable which we connect to the spotter. So this then transmits subsurface data to the spotter up to through your API or your dashboard, all in real time as well. So at the moment, we've got fully integrated temperature and pressure sensors, as you can see here. But we, as of October this year, so by the end of October this year, we will have a single point current meter available. So this is something new, something exciting. And so before then, we'll have customers using it and testing it on our behalf as well. So we'll have people using it and testing it before we even release it as well. So this is something that we'll have ready. If you're interested in the current meter, then I'm going to send out a few spec sheets after the webinar, just so that you guys can all have a look through it and see all the new stuff that we're trying to work on as well. If you're not interested in a current meter, we also have already released the bristle mouth development kit. So this is sort of an interface between whatever sensor, subsurface sensor you'd like to integrate and the smart mooring. So you can integrate whatever subsurface sensor you'd like, normally with an RS-232 connection. And then with a bit of coding, we can actually integrate that to the smart mooring and start sending real-time data and communications through the smart mooring to the spotter and then transmitted back through, it would be through an API at the moment. But yeah, we have the capabilities to do that and expand our sensor network. So that would be great, and it would be lovely to get everyone's feedback on what sort of sensor they'd be interested into integrating as well. So these are some exciting new developments. So just a quick slide just to end things off. This is just a great slide to show how easy, rapidly deployable and versatile a spotter is. So we've actually thrown spotter out of aircraft. So you can see it has a nice little skirt on it to drop it out of aircraft to then do hurricane monitoring. We can moor it with a smart mooring or a standard mooring. So Sofar also provide standard moorings if you're interested in that as well. Or you can have it as a free floating drifter as well. So there are multiple opportunities in different ways to moor a spotter. So Antti, if you would like to share your screen and take it away with some of the work that Luode are doing with our spotter.
Will do. I hope you are able to see it now.
Yes, we can. Brilliant. Thank you.
So, good afternoon, good morning for everyone. So, my name is Antti Lindfors, and I'm the director on the Luode Consulting, Finnish-based, privately owned company specializing on currently on the offshore industry and then on freshwater application, as well as some numerical modeling, mainly related to the energy sector clients. And as you can see, I'm actually sitting on the bridge of one of our survey vessels, which just came back from the sea like half an hour ago to do some installations and benthic and sediment sampling. So decided to have the presentation really on hands-on experience straight from the sea. So if you have questions or if you cannot hear or do not understand something that I'm saying, just interrupt me, and then in the end of the presentation we have opportunity to have ideas and share the thoughts and questions and so on. But immediately if there's something interesting popping out, just interrupt me and ask directly. So no need to wait for the end of the show. There's a short content list. What my idea is that we could go through today. So shortly about the typical projects. These are mainly related to now offshore wind industry, because that is kind of blooming branch and blooming sector here in Scandinavia. Not only in Finland where we are located, but as well in Sweden and in Denmark, of course, already many years ago. But now the pressure is moving towards the Baltic Sea, and it seems to be that there are quite many projects ongoing, as you will see soon, mainly related to the real offshore industry. So we are actually working quite far away from the coastline. So, but that's something that we will come soon, and you will see the ideas. Something about the instrumentation we are using normally, not only related to the wave and wind monitoring, but you will get kind of overlook what kind of things needs to be taken into account when you are planning the wind farms or the wind parks. Then something about the Sofar Spotter products, how accurate wave data supports these kind of projects, how it should be utilized, what kind of things you should take into account when planning the installations and moorings. Couple slides or 1 or 2 slides about the Baltic Sea conditions. We have some specialities in the Baltic Sea, mainly because we have brackish water pool, so we are not really working on the real oceanic waters in here. We have relatively shallow waters in here, and then we have kind of historical ballast or heritage, mainly related to the First and Second World War, which needs to be taken into account as well. And then, as mentioned already, in the end of the presentation, there's a time for questions and ideas if you have some ideas or questions you would like to share. So this is kind of slogan what we have been using already since the Luode was established already in 2003. So we are providing data for clients' needs. So we don't make measurements for fun or just because we could do measurements. There's always the question that our client is putting into the air and asking, like, how we could solve this, or I have problems with this kind of things, or I would like to have more information of this kind of physical or geophysical or oceanographic questions. What can be done? So that's kind of driving force for Luode. So we are providing data sets, we are providing reports quite often and recommendations for the clients, but quite often the clients has own scientist or own engineering department who is needing this kind of information. So that's the main purpose of the company. So we are providing state-of-the-art data for the clients, and then they can utilize it as they want. Then one slide about the state of offshore wind projects in Finland. The main reason why Finland and Sweden are kind of hotspots at the moment is that we are very safe from the governmental point of view, and the legislation is very straightforward in Scandinavian countries. So there are no big mysteries when you are investing like billions of euros or billions of dollars on these countries. So these are quite simple in that sense. But of course, as you can see that how many projects are ongoing at the moment, this is something that I know that the authorities, both in Finland and Sweden, they were not very well prepared on this kind of high level of activities. So you can see that currently, this statistics was taken a couple of weeks ago. We have 32 projects ongoing in Finland only. And if you think about the megawatts installed, what they are planning, that will be 57,000, and traditional big scale nuclear reactor in those what we are using in Europe are typically from 1,000 to 1,500 megawatts. So we are talking about units which are more than 40 nuclear power reactors installed in the one country, which is of course overwhelming and much more than our grid system, for example, can handle at the moment. But this is the status. The offshore industry in general is growing very quickly in Finland, not only because of the power, but there are already clients who are investing on the green steel, which means that instead of using coal, they are planning to use the hydrogen. So the most of the electricity produced on the offshore wind farms will be used for the hydrogen solutions and hydrogen products, steel products, and kind of different levels of maritime and shipping industry fuel in the future. And as you can see on the table above as well, that most of the projects are still in the planning phase, which means that information what we are collecting, for example, is really highly needed at the moment. So there's urgent kind of markets for this kind of data. And what is quite obvious as well, you can see that only one offshore wind farm or wind park has been permitted in the history in Finland. Which means that we have lots of new authorities who are responsible for the permitting and analyzing and reviewing the environmental impact assessments. This will be completely new area for them as well, which means that there are lots of open questions, not from the client side, but from the authorities side. So they are asking what kind of effects this will have and how this should be treated and how you think about this and this. So there are lots of questions coming both from the end user part, but from the authorities side as well. Then something about the typical projects and clients' needs. In this case, I will just call clients' needs, but quite often these are the needs from the permitting authorities as well. They would like to have this kind of information available. What we do is be kind of data provider or integrated ocean data solution provider for offshore wind industry. We collect data, we help with the permitting and the planning phase, and then quite often we analyze the data and provide kind of reports for the end user and for the designing departments of the different offshore wind projects. And quite typical, I have misspelled wave that, but the wave data it should be, but these are kind of critical information. So what is needed is of course the wave and wind data. Wind data is critical for the production side, of course, but keeping in mind that the offshore wind turbines needs regular servicing and maintenance visits. And one of the specialties in the Baltic Sea is that in certain locations we have annual sea ice present 6 months per year, which means that the service visits are very complicated tasks to be conducted during the winter period, meaning that there's a high emphasis to have all the servicing done and all the maintenance done before the ice is coming and the sea is freezing. So therefore, not only the designing department or the technical department, but as well the maintenance people are already thinking about like how often we can go there and what kind of conditions we are facing. Another thing which is quite critical is the current speed and direction data. So kind of interesting to hear what Jasmine told that there will be single point current meter available for the spotters as well in the near future. So this is something that is needed mainly for the environmental impact assessment. In the Baltic Sea, the current speeds and now let's talk about the current speeds. They are normally quite low. We don't have tide in the Baltic Sea, for example, which means that all the currents are driven by the lower high pressure system and wind. So this makes it slightly more easier from that point of view if you compare with the coastal waters in the oceanic region. So we don't have the tide. But as mentioned earlier, we have the current speed related to the high pressure systems. Then we have the ice, presence of the ice, which brings it together that during the winter conditions, we don't have kind of solid fixed ice, which is not moving at all, but quite often we have the situation where the whole ice sheet or ice cover is moving with not only with the winds but as well with the currents, which means that the forcing what the bottom mounted wind turbines, for example, are like facing is much higher than in the open water regions. So the windmills and the foundations needs to tolerate the moving sea ice as well, and reaching processes and quite often we have really thick keels when the ice is reaching in the Baltic Sea. The ice keels might end up down to 20 meters below the surface, which means that we have really huge forcing, which needs to be taken into account when you are planning the foundation method, for example, for the windmills. Another parameter which is interesting is of course the water quality data. This is mainly related to once again on the environmental impact assessment phase. Then sediment and benthic data is something that we are collecting. As you can see, there's a map of one client's project kind of designing phase. So you can see the actual wind parks. There are two huge areas. This is almost 100 kilometers long outside the Finnish coastline. And as you can see that we are almost 50 nautical miles, 100 kilometers away from the nearest shore. So the sites are really huge and they are quite far away. And this is, for example, typical setup. The black dots, what you are able to see maybe, or the black titles here, those are the locations where we have the spotters installed at the moment. The white titles, these are the locations where the authorities want us to collect, for example, sediment and benthic data, water quality data, and kind of online parameters as well. But this is quite typical setup on the one wind farm. So we have the actual project site where we have 3 to 5 spotters installed, and then we have the pipeline and the cable corridors, which are instrumented as well. And then we have the sediment and benthic samples in between, which are running all the way from the production site to the shore where the landfall locations are. Geotechnical data is something that needs to be collected. Munition data or the unexploded ordnances data is something that is critical. And then information about the migrating birds and marine mammals is something that needs to be taken into account as well. Once again, in the Baltic Sea, we have very limited number of marine mammals, so mainly we are targeting on the seals and occasional harbor purposes. So we don't have the big whales at all in the Baltic Sea. Some words about the instrumentation, how it is done, and what kind of instruments we are using. So we have, of course, quite large range or variety of devices to make all the needed parameters available for the clients. And as we are here hosted by the Sofar company, so this is one critical instrumentation what we have been using and chosen to be used for this kind of projects is the wave and wind data from the spotter systems. The reasoning behind why we chose the Sofar Spotter system, we will get back to that later on, but there are 3-4 quite obvious reasons why that was our choice of weapon for this kind of industry and application. For the current data, currently we are using bottom-mounted ADCPs, offline mode, so we don't have online systems as the sites are so far away and quite often very deep sites, so we don't have access to the real-time data on the ADCPs. And the same situation with the ice data, of course. During the ice conditions and winter time, we are not able to use the buoy systems because they don't tolerate the drifting ice. So during that time when the ice is present, we use bottom-mounted ADCPs and satellite images, of course. Same with the water quality data, typically done with the bottom-mounted sensors, because the critical parameters and the critical phenomena taking place related to the construction, for example, they are normally happening very close to the bottom. So we are mainly interested about the sediment spreading and impacts on the seabed. So therefore, most of the water quality data and of course all the sediment and benthic data is done on the seabed conditions. For the geotechnical data, vessel-based surveys, this is something that international competition is really high in the Baltic Sea. So there's only the money talks when it comes to the geotechnical data. So who can provide cheapest survey kilometers normally wins this kind of projects. But when it comes to the for example, wave and wind data or collecting sediment data, then quite often the local consultation companies are needed because they have the specialties and slightly deeper understanding what kind of things you are supposed to find and what you should take into account when planning the actual studies. UXO data, normally done on the vessel-based surveys, but then we have some desktop studies available as well for the old minefields, for example. And then the most critical and most difficult one at the moment is the information about the birds and marine mammals. And this is something that we have been a little bit talking about with so far already, how the passive acoustic monitoring could be implemented with the spotter buoys, because that would be kind of really nice add-on for the future projects. So you could have real-time access on passive acoustic monitoring data. Then some extra words and ideas about how accurate wave data supports the short and long-term planning. And this is kind of case study spotter, why we chose the spotter. I will make the screen more visible for me. So typically what we do is that when we have the project site and the project area established, then depending on the size and the location, we normally install 3 to 5 spotters on each site. At the moment, we operate some 15 plus buoys, so the numbers are relatively small, but if you keep in mind that all the parameters that are recorded, this is still relatively high number and actually quite critical parameter for our client to collect especially the wave observation information. As mentioned earlier, the main target is to help with the technical site assessment and designing and collects kind of high resolution information from the cable and pipeline corridors for modeling purposes. This is something that quite often people don't realize when they are talking about the offshore wind industry. They are only seeing, of course, the wind turbines and the foundation and big white towers. But at the same time, which is invisible for the everyday people, is that there's a huge grid or network of cables connecting all the individual wind turbines to the central station or the transformers, and then there's a huge number of really thick cables, AC or DC cables, running from the site to the shore, where you have the landfall location and then you have once again the connection points to the grid. And quite often the area which is impacted by the presence of the offshore wind industry is actually mainly coming from the pipeline corridors, pipeline meaning the hydrogen production on site, and then the power cables running from the actual project sites to the shore. So the actual footprint could be much larger on the cable corridors than it is on the actual wind park side or on the project side. And this is especially the case when you are thinking about that most of the sites will be pushed further and further away from the shoreline. So quite often we are now talking about distances up to 100 kilometers from the shore, which means that normally you run with 3 to 6 cables, and each cable needs some clearance in order to have servicing available or in the future. So meaning that individual cable corridors could be several hundred meters wide, and then you have 3 to 6 cables running 100 kilometers from the offshore to the shore, meaning that actually you are covering several hundreds of square kilometers only with your cables. So this is something that needs to be taken into account. And servicing of the cables is normally done in the very harsh conditions, and this is once again something that needs to be taken into account. What kind of wave conditions there are, what kind of cable fixing vessels are available, and in what kind of conditions they are able to operate, because might be that the weather conditions are too bad for fixing the cable, meaning that there will be delays or you have to kind of shoot down your production on the site, which becomes very expensive. So these kind of questions have been asked by the technical departments of the project organizations. How often we can go there? In our everyday living or life, Luode uses spotter wave observations to support our own service visits. So when we are revisiting the sites or installing new instruments or swapping the instruments, not only the spotter buoys, but when we are, for example, changing the passive acoustic monitoring devices or ADCBs, we are using the data to see that if we can go there with our smaller vessels or if we need the big ship, which of course becomes much more expensive. So if the conditions are fine, if the information collected on site looks promising, then we can go there with the smaller vessels and kind of save money and save time. And then some criteria why we decided to select the spotter systems. We have background with different really huge buoys as well, and then we have kind of medium-sized buoys in the past. But then we realized that we were doing actually one acoustic monitoring testing with the spotter buoys. The spotter was used as a kind of data link, but we realized that this could be quite handy instrument for the wave instruments, where it is originally, of course, meant to be used. And the main benefit is, of course, it's very practical to deploy. And then when it comes to the consultation business, the flexibility of the different data transmission options is very critical. So not all the stations are located so far away that we have to use the Iridium satellite-based data transmission. Quite often, the buoys could be so close to the shore that we have the cellular or the GSM network available, which is of course much cheaper way, but quite flexible way, especially in our case where the monitoring periods could be very short sometimes. So we don't have to keep the satellite subscription ongoing, because quite often the systems could be sitting in our shelves for 3 months or 4 months without any use, and then suddenly the client says that now we need the wave information. So they are very easy to take into the action and without any big preparation time needed. And of course, the self-power work is critical. Everybody knows that how expensive it is to go to the offshore site and just to change the batteries and then return to the shore. So if you can have the systems that are self-powered and you have full control, online control on the battery levels and status of the system, makes it very easy for us to operate the systems and see that when we are servicing them or visiting them, it is done on demand instead of just having fixed intervals that now we go because we haven't been there in 2 months. Instead of that, we can check that, do we have to visit the site? Do we have to swap something? Or is there something which is broken and we have to change? Then we have the online access to the data, and then we can make the decision. Some words about where the wind and wave data is needed. Many of the things have been mentioned already during the presentation. So the one critical part is the technical site assessment and designing. One question is are year-round conditions optimal for the construction and offshore wind farm? We already know that no, they are not. So we have certain period of the time, certain period of the year when we are not able to construct the offshore wind farms in Finland. Not only the wind, but could be that we have freezing conditions, or we have the presence of the sea ice, or we have the risk that especially in springtime, that the seasonal variation and the local variation between southern Finland and northern Finland are very huge. So it might be that we have almost full summer already in the southern part of the Baltic Sea and the Finnish waters, while at the same time in the northern part there's still presence of the sea ice. And when the ice breakup is taking place, quite often these huge ice flows start to float with the currents, and then they are causing risk on the construction vessels. So this is kind of balancing always, like when you can go there and when you can start your construction work, and when you can say that now there's no big risk anymore for drifting ice to come to spoil your work, for example. Another thing is that where we are using the wave information is that what kind of environmental consideration at the site there are, what kind of protection we should be prepared for the cable and pipelines. As mentioned earlier, the Baltic Sea is relatively shallow, and we have lots of kind of shallow banks still in the offshore. So it might be that in the certain location where the cable are going through, or the actual wind turbines are designed to be placed, could be that the water depths are less than 10 meters, meaning that you have very harsh conditions on the cables and on the foundations, and as well on the installation vessels. So this kind of information is or the questions are tried to be answered with the relatively high number of the wave buoys what we are now using. Then one question is that what kind of sediment spreading during the construction could be expected, and waves are of course one factor on those, and the wind is one factor on those. So we have toxic or contaminated bottom sediments quite in the many places in the Baltic Sea. So once you are for example doing the monopiling, or if you are having gravitational based wind farms, meaning that you have to do some dredging or you have to do some drilling, or the pile driving in the areas where you might have contaminated sediments. So you want to know in advance how far away, for example, these contaminants could be spreading during the construction work. And then one potential use for the wave information, this we already mentioned as well, that can the maintenance visits be performed safely in the current wave condition at the site? What seasonal periods are optimal for the maintenance? This we kind of know, of course, from the statistics, but this is something that for example, the Finnish Met Office, the Meteorological Institute, they are collecting the wave data, but the number of the locations where we have the wave buoys is less than 10. And I think we have more than 1,000, maybe 1,500 kilometers of shoreline in Finland. So you can imagine that having less than 10 wave buoys installed along the coastline, which is 1,500 kilometers long, is not enough when you are having the targeted information needed from the sites, actual construction sites. And this is, of course, very critical information. How many standby dates are expected? Not only on the service visit, but on the construction and actual the installation phase. The installation vessels are extremely expensive, and there are very limited number of those available in the world. So you want to know in advance how many days the weather is so bad that you cannot do the maintenance visit or you cannot do the installation. And this automatically can be transformed into the euros or dollars, of course. Couple words about the Baltic Sea conditions. The sites are often very far from the shore. This is, of course, becoming more and more typical in all over the places, international as well. So the good places are taking, so the wind farms could be built in the deeper waters, which means that the wind conditions are harder, but it means that visiting the sites will become much harder as well. Then quite often we have very limited or no access to a cellular network at all, meaning that the work which is done in the region needs to be based on, if you want to have real-time data, you need to have satellite connection on the instrumentation. But at the same time, it means that the safety issues on the smaller vessels could be critical. So if you don't have access to the cellular network, meaning that all the emergency calls needs to be taken through the satellite network. So this is kind of safety consideration in the Baltic Sea as well. So we don't have full cellular network coverage in the foreign side and in the offshore conditions. Then if you remember the first slide where we have the statistic of the ongoing projects and in the planning phase projects in Finland, the competition against different projects and among different projects is really huge at the moment in Finland. As I mentioned, that the legislation and the standards on environmental impact assessment and permitting phase, they are very high in the Scandinavian countries. But at the same time, for example, the Finnish government, who is giving the survey permits for the exclusive economical zone of Finland, they cannot limit if one project company is saying that we want to study this area, they cannot have kind of privilege to have the site on their own, meaning that another company who is planning to invest and investigate the same area will get the permit as well, meaning that we have quite often situation that the good sites are kind of occupied by one or two or three competitive offshore wind developers at the moment. And there's, of course, the speed is an issue. So if you can deliver and file in your environmental impact assessment earlier, might be that you will get some benefit from the governmental point of view. And therefore, at the moment, quite a huge numbers of the projects are in the planning phase, meaning that this kind of information we have been talking today is kind of critical for the many clients. And quite often the situation is that the similar projects and exactly the same areas are instrumented, and instrumentation is done by the overlapping companies or overlapping projects, meaning that sediment sampling and benthic sampling, for example, could be done on the Monday for the one project developer, and then next Monday for the same area for another company. So that is kind of situation in the Finland at the moment, that you cannot have certain sea areas marked for your own projects, meaning that there's quite a lot of competition ongoing between the projects at the moment. Then something which is kind of critical on the Baltic Sea as well. There's picture of one mine clearance operations, and I just pick up one line from the net. So both during the First and Second World War, more than 150,000 mines were placed on the Baltic Sea, and still up to now only 20% of those have been demolished or removed or destroyed in clearance operations, meaning that we have more than 100,000 unexploded ordnances still present in the Baltic Sea. And the worst situation, of course, would be that you would build the wind farm in the area where you have the high activity of old mines, for example, or you have the munitions, different type of munitions, which could be exposed when you are dredging, for example, the cable corridors, or you are doing the dredging work for the foundation. Might be that you are ending up in the place where you have the high risk of hitting the old sea mine. And this is, of course, very, very expensive operation to do the mine clearance. This is not only, of course, specialized or special thing in the Baltic Sea, but of course the number is relatively high, what we are still facing here. And then we have contaminated sediments, which are mainly related to the industrial period. And then we have some geological reasons why we have in a certain location we have lots of contaminated sediments, which make it very difficult to have, for example, the dredging permission from the government or from the environmental authorities. And therefore, once again, the numerical modeling is needed, and for the numerical modeling we need the current and wave information to produce and have certain level of confidence on the numerical models what the different project organizations are using. This is my last slide. So if you have any questions or you have ideas or things that should be taken into consideration, please let us know. And so I think that was the end of my presentation, and I don't know if you have got some questions. So Jasmine can maybe take over now.
Brilliant. Thank you, Antti. That was brilliant and really insightful as well. So thank you very much for that presentation. We do actually have quite a few questions. So I'd be interested. We'll just quickly flick through some of those. So there's one for me, which is about the depth limitations of the current meter. So the smart mooring is limited to 50 meters depth, just for obviously communication and power purposes. Might expand, might not. I'm sure it will. But yeah, we're not limited with the current meter currently. So with the current meter, you can have 2 per smart mooring. It's dependent, obviously, on the configuration that you have with some of the other sensors as well. So if you're interested, we can have potentially up to, you can have 4 Sofar temperature sensors or 3 RBRs. So there's different configurations that we can talk through. So if you're interested, we can talk through that configuration. There's also another interesting, there's quite a bit about how you moor them. So someone asked, how are you mooring the spotters currently? Are you using single catenary design, double catenary? I know you mentioned that obviously it was in multiple different depths, obviously dependent on what location you were. And then also in terms of the supporting buoy, do you have obviously large guard buoys just for more visibility when you're mooring the spotters?
in our case, we are using single mooring line, and actually the sinkers itself, they haven't been that heavy because we realized that you don't have to have extremely heavy sinkers because we have soft sediments and muddy sediments. So quite often we use concrete weight, and then we have some mooring chains, which is then transformed into the non-floating central line. And we always use the high visibility kind of dots or central buoy on the surface. And then there must be some nice English term for that, but we call it dock leach. So there's like floating line leaving from the central buoy to the spotter itself. So that's how they are installed in our applications.
Yeah, brilliant. Yeah, I can also say from obviously past experience, especially working in offshore wind farms, so people sometimes don't necessarily need to use the big buoys, because if they're obviously quite contained, obviously if you've already got an established wind farm, not many people are going to go in unless they're doing maintenance and checks and stuff like that. So usually if you inform them, they know that there's a buoy there. But yes, people do use really large big buoys just next to obviously the spotter. Obviously it's cheaper than getting a really large wave buoy that has all the parameters inside it, just as sort of like a reflector. People like to have lights on it, for example, just as sort of like a little bit of a beacon for when other people are within the area as well. So yeah, people have used that obviously in my experience with other customers that I've been working with. Someone asked if we're working at high latitudes, if we can add extra high capacity batteries. So no, don't change any batteries, please don't, because it's a very self-contained system, which means obviously it's really easy to replace the internal system. So we can isolate problems really easily. But yeah, please don't change the batteries. We do have other things in place that we can actually improve the efficiency of the buoy itself. So I mentioned that we have a new firmware release, which is GPS Sleep. So that's something that's just been released. It's really great. We have a whole blog post on it, so I can share that with people that are interested in working in these really high environments. And there's also other stuff we can do. We can change the frequency of the LED light. Also, we need to make sure that we're in line with local rules and regulations when you're mooring as well, because some people have there's local regulations, so we have to be in line with those, but we can improve the efficiency of the buoy. So if you're interested in improving it because you're working in high latitudes, then there's so many things that we can do, and we can discuss that as well when you're going to deploy in those locations as well. So someone asked, because you use obviously multiple spotters on your sites, approximately how big are the sites that you're working on, Antti?
Yeah, the largest one are, I think, 120 kilometers long, and then the width could be 30 to 50 kilometers. So I would say typically 200 square kilometers up to 500 square kilometers, and the biggest one are, I think, close to 1,000 square kilometers.
Yeah, brilliant. Is there a specific spotter array configuration that you use if you're using multiple at one site? Yeah,
on the actual site itself, we try to just have spatial coverage covered enough so that we have therefore three to five on the actual sites where the turbines will be placed. But then on the cable corridors, we are selecting the location so that they are representative for the different depth gradients. So we know what kind of shoaling effects and what kind of breaking of waves could be expected. So on the cable corridors, there's a special way to select the sites. And for the project site itself, where the turbines will be placed, or the park itself, they are just more randomly placed, but the idea is to have enough coverage for each individual buoy.
So roughly how often do you go out to maintain the buoys?
If everything goes well, then the idea is that we install them in the spring, which is normally in April, May, and then we recover them when the ice formation is coming. So when the temperatures are dropping below 1 degree Celsius, so then we try to pick them up. So hopefully no maintenance is needed But if yes, if so, then it would be, I would say, in the mid-term. So after 3 months, we would visit the site and mainly do the cleaning and check that the buoyancy is enough, and the central buoy what we are using is floating nicely, and if needed, then we are replacing some mooring lines and so on if there's like weakening or.
Yeah, no, definitely. Yeah, we usually say roughly about 3 months, but obviously maintenance checks are very dependent on your location. If you have more biofouling in a specific area, obviously a lot of people who, obviously the people that we work with, you know, you're working in on an area that you're pretty much used to. So obviously we like our clients to obviously use their own initiative, because obviously, you know, you guys know the environment much better than probably we do. Yeah, I would definitely say do an initial check, clean it. Obviously we don't like to do, we just want like fresh water cleaning the buoy just to make sure it's all good, and then you can pop it straight back out. So there's a little maintenance as well. So it's just a quick wash straight back in, and still collecting data.
Mainly the shackles, I would say, the shackles and of course the mooring lines. So those are something that would be good to check. And if you have very corrosive waters, like if you have high level of salt, then you have to check that all the materials you have been using are compatible with each other. So that's something that we have realized, that the cheapest shackles, for example, they are not normally made on the really good stainless steel. So it might be that you have to change them once every 3 months, once in a 4 months period.
Yeah, no, definitely. Some great input there. So someone said, from your perspective, Antti, how are weather forecast providers lacking or different in comparison to the data that you're collecting, in particular for wave and wind statistics?
I would say in general they are good, but the main benefit why we are using so many instruments on each side is that the spatial resolution is not enough. So quite often we have the situation that on the southern part of the wind park the conditions are excellent, and at the same time 100 kilometers north there might be really high wave activities, and that is something that we would try to understand, that the governmental weather forecast is not high resolution enough for this kind of applications.
Yeah, because some of the work that we've been doing with some companies in the UK, they're localized weather forecasting companies. So obviously when we're working on specific sites, we want to be very accurate. And I think the way to improve those forecasting and those accuracies are to be having real-time data input. It's just a bit of a no-brainer there. You know, if you have real-time data, it's more accurate than something that can be modeled. But we can definitely improve modeling, and we can also work alongside those weather forecasters to help provide those improvements and start doing that as well. So yeah, it is definitely something important and something that, you know, obviously we can all help with. So yeah, I think we've answered quite a few questions, and there's obviously a few questions left over, but I think there's something that we can, obviously I can message you guys all privately, and I can bring Antti in as well and answer any of those questions you guys have as well. Thank you so much again, Antti, for joining us. It was honestly a really great and insightful discussion that we've just had, and thank you all so much for joining and all your questions. We really appreciate it. And I look forward to hopefully seeing everyone again soon.
Thank you. And if you have additional questions, so please just write me an email or contact through the Jasmine. So we will definitely like to help you. And if you are planning the installation, so just let me know.
Brilliant. Thank you very much, everyone.
Yeah. Cheers.